everyone. In this problem, we have a swimming pool that is 60 feet long and 25 feet wide. Let's think about how I want to draw this thing. Let's go like this. Okay, I'm going to assume that that is not changing. Its depth varies uniformly from 3 feet at the shallow end to 15 feet at the deep end. Okay, so let's see. So here, we're supposed to be at 15 feet deep. And here, we're supposed to be at 3 feet deep. And uniformly just means this is going to be a nice straight line. It doesn't like drop off or anything. It just has a nice even slope until it hits the 15-foot depth. Okay, so that's the shape of our pool. The pool is being filled with water at a rate of 800 cubic feet per minute. 800 cubic feet per minute. Water is filling. And we want to figure out at what rate the depth is increasing at the deep end when it is 5 feet deep at that end. Okay, so let's see. 800 cubic feet per minute, I'm going to call that dV dt. And this is the volume of the water. So the volume of the water in the pool is increasing by 800 cubic feet per minute. We want to know, okay, depth at the deep end. So let's say, and we're interested in what's going on when it's around 5 feet deep. So let's just kind of draw it around there. Let's say, I'm going to use H. D's are always confusing. D, dt, somehow that just seems really awkward. So I'm going to call it H for depth of water. We want to know what dH dt is when H is 5 feet. So we need a formula that relates the volume of the water to its depth. And at first I think this looks really tricky, but let's see. If we go along here, see if I can sort of make this look how it really is. And then we have this coming up. Okay, so I don't know how much that actually helps, but what we have is like a triangular wedge of water. So this is a triangle over here, and in fact it's a right triangle if you want to mark that off. It is stretched out by this 25 feet. So this is one of those prism shapes. This is a triangular prism. To find its volume, and I would expect you to be able to figure this out on your own, its volume is going to be the area of the base. That's the base right there. So area of base multiplied by the height of the shape, and we're kind of picturing this on the side. So it's 25, it's stretched out by 25 feet. So the area of a triangle, that triangular base, is 1/2 base times height. And height we will keep exactly as it is because we already have one of those, but we need to do something about the base variable. So that's the base on top. Everything's all kind of upside down here. So the height is right here, the base is right here, this is the hypotenuse. So this is one of those where you want to ask yourself, if I pick a specific depth, can I make the base be whatever I want, or is that predetermined by the pool? And the answer is it's predetermined by the pool. So what we're looking at again here is, let me make sure I do it right, similar triangles. But this one's a little tricky because you basically want to completely ignore this top 3-foot rectangle right here. I don't know why I just highlighted it in. And just look at, here, let me redraw. If you look at this thing from the side, like I said, if you're ever struggling with a 3-dimensional shape, you can always kind of just look at a cross-section. Look at it straight on from a side or split it in half and look at it. So we have this 5-foot depth that we're interested in, but we're not going to fix that because we're interested in some change happening. We have this H and this B, and we know that this entire height here is 15, and we know that this entire length is 60. The problem is this top 3 feet is kind of a distraction. If we want a triangle, we just chop it off completely. So this is now gone, and really all we're left with is, here, let's cross this out, 12 feet right here. So we have, where did I put my orange? We have this bigger 12-foot height, 60-foot base triangle, and then we have our smaller height H, base B triangle, and we are trying to find B in terms of H. So I'm going to say that B over H would have to equal 60 over 12. 60 divided by 12 is 5, so this is telling me that B is 5 times H. So, back to my formula, I have 1/2 5H times 25, which is, 5 times 25 is 125 over 2H squared. Okay, finally, so this is the hard work, right, getting the formula. And then we're ready for a derivative. So we're going to say that dv dt is equal to, so the 2 drops down in front, which cancels out the 2 in the bottom of the fraction, and we get 125h, and then don't forget the chain rule, dh dt. We know that h is 5, and dv dt equals 800. So we have 125 times 5, which is 625, dh dt. Okay, so to jump all the way over here, dh dt is going to be 800 over 625. I could cancel some 25s, but I'm going to go ask my calculator because I don't want to think that hard. Okay, calculator. 800 over 625, 1.28, and this was how fast the depth is changing, so this should be feet per minute. So that's my answer. And it's good that it's positive. The volume was increasing, the amount of water in the pool is increasing, so its depth should be as well. Thanks for watching.